Hi, everyone. So lots of great talks today. We'll try to get through this quickly. So today I want to talk to you about the work we do at Meta to accelerate the pace of scientific research. Specifically, I'll talk about what we do to help scientists stay on top of their field of research and all the publications that are coming up. I'll talk about how we help publishers and speed up the gap between submission and publication of scientific literature, and then how we help identify new and emerging concepts and ideas in science. So science has scaled up in an astonishing rate. Since 1911, there's been over 26 million publications in biomedicine alone. There's 4,000 to 5,000 new papers coming out every single day. More and more we see cases where findings in one area of research have profound impact. CRISPR is one great example. For example, it started up in virology and then got up in gene editing. But with the pace of scientific global research output, staying on top of everything and getting a holistic view of everything that's going on is basically impossible. And those are some of the challenges that we aim to solve at Meta. We try to read, understand, and create structured connections across the scientific knowledge graph. Our mission is to unlock the scientific and technological insights that are in publications through machine intelligence. Our content comes from a variety of sources. We have partnerships with 40 of the leading publishers, getting access to what is basically, as far as we can tell, the largest closed access full text corpus of scientific literature in the world. And we use this corpus to create what we believe is the largest scientific knowledge graph. We have connections across over 37 million scientific entities, and we create connections, our knowledge graph include entities such as papers, authors, institutions, and most journals, but most importantly, the scientific concepts from the papers, covering things like organisms, diseases, genes, and proteins. Scientific literature is some of the densest, most information-rich documents around. In this case, big data doesn't just mean volume; it means the complexity of the problems. On the knowledge graph, based on those knowledge graph, we've created several services. And the first one I want to talk about is MetaScience. MetaScience is a free literature exploration engine that allows you to basically navigate our knowledge graph and see the science through, in the context of authors and particular domains of research. It allows you to essentially explore the knowledge graph, and through our recommendation system, find new and important connections that you may not have known about. For staying on top of the latest research, you can use the feed. So the focus feed allows you to basically create a personalized timeline of research that is relevant to you and your focus area, and basically make sure that you don't miss any paper that comes out. With 4,000 papers coming out every day, staying on top of this is extremely hard. Our broad feeds allow you to follow huge swaths of science, and we bubble up the most important and impactful papers that are coming out in real time. Next, I want to talk about Biometrics intelligence, or BI, and take a look at this paper from DeepMind. So this one got published in October 27 of this year. But you might notice that it was submitted in the beginning of January. So it took over 10 months, almost a full year, for one of the highest profile research groups working today out of one of the highest research profile companies working today to get published in a high profile journal. And this is quite typical. So 1 year is basically almost the standard. A year and a half, 2, and even 3-year time turnarounds definitely happen. And this is all assuming that your paper doesn't get rejected, and then you get to start the whole process in some other journal. It's basically the same process that's been around for the last 400 years. We have better management system of submissions. We've got faster communications, but the decisions are being made pretty much the same way. And In fact, the gap between submission and acceptance and publication has been on the rise for the last couple of decades. So at the core of our BI service is our ability to predict the impact of a manuscript before it's even published. We measure impact using obviously citation counts, but also eigenfactor. Eigenfactor is basically running PageRank on the citation graph, or if you prefer, taking the primary eigenvector of the citation matrix. It's a bit more than that because unlike web pages, citation graphs are time dependent, so you never get any cycles. But that's basically what it is. You look at the correlation between a paper's eigenfactor and the journal it was published in, you'll see 20% correlation. Our algorithms are able to predict it at almost 2.5 times better at 53% correlation. Now, we don't actually analyze the scientific merit of the article in the sense that we don't validate that the methodology is right, that the analysis is correct, and leads to the conclusion that are discussed. But what we do is we evaluate the importance and the impact of those conclusions in the context of our knowledge graph. We use a combination of metadata features extracted from the knowledge graph, as well as deep analysis of the text of the manuscript. Around this ability to predict the impact of a paper, we've created the Biometrics intelligence service, which generates basically a complete report and puts it in the hands of editors and publishers to help them make data-driven decisions. Our report includes additional information, such as it highlights the key concepts discussed in the manuscript. We also can quantify the fit of the manuscript to the journal it was submitted to, and even suggest additional appropriate journals to publishers with multiple titles under their umbrella. We also recommend reviewers who are best equipped to assess the validity of the science for the peer review. We believe that peer review is a critical path for publication. We're not trying to replace the peer review system. We're not trying to replace the editors. It lends a level of credibility and legitimacy to the whole process of science, right? What we're trying to do is put data in the hands of the decision makers to help them make faster and more efficient decisions, and not just make guesses and take their best guesses, basically. Finally, I want to talk about horizon scanning. So horizon scanning is a tool that makes predictions about what's emerging in terms of concepts and new ideas that are coming out. If Biometrics intelligence is predicting impact at the paper level, horizon scanning makes those kind of predictions at the concept level. We can analyze all the content that we have, as well as ancillary data like patents, and we extract entities and concepts out of it. And then we create indicators or features around those entities that cover things like usage, adoption, context, novelty, and more. We use those features to evaluate the current global prominence of these concepts and ideas, and then predict 3 years out what that's going to be in the future. We work with several partners in government, in pharmaceuticals and publishing, and to help them identify new R&D initiatives for granting or investing purposes, identifying new drug targets or for drug repurposing, as well as identify gaps in their services and products. We actually talked right now with space agencies to help them design the next set of experiments to be carried out 400 kilometers above the Earth. All these products that I've talked about, meta science, biometric intelligence, and are aiming to identify and alleviate a bottleneck in the scientific process, going from identifying the problems you're going to work on, carrying out the research in connecting with new colleagues and collaborators, as well as facilitating the publication process. At Meta, we believe that ultimately unlocking the scientific insights in papers begins, but by no means ends, with enabling our scientists and researchers to be more effective, essentially. And we aim to put the tools in their hands to enable them. So hopefully that was sweet, and I know you guys all want food, but thank you very much.
Okay, any questions for Ofer? Can you help with electronic health records?
We don't have those at the moment. I think we would love to get our hands on it, but that's that's delving into the clinical applications of our technologies, which I think definitely there's a lot to do there. Right now, we've been focusing on sort of the insights that scientists are deriving.
So I wonder how much of a problem do you think potentials for gaming the system?
Yeah.
The impact of past papers, but once people start knowing what you're doing, maybe they start thinking their papers increase their measure of impact.
That's a really great question. So this is something that I've been definitely cautioning about. First of all, so the system is now available to publishers that are starting to make use of it, and we want to make a version of this available to authors as well, so they can advance or get those insights and make their decisions faster. But yeah, I think that's ultimately a very real concern, and we're continuously working to improve those algorithms, put more and more emphasis on the text and the conclusions. We've started working now on a knowledge discovery system that is to extract really end-to-end what's in the paper in terms of the methodology, the analysis, and the conclusions, and be able to evaluate it sort of holistically, the entire thing. So, we're not there yet, but we're definitely working towards that, and hopefully it'll get harder and harder to game the system that way, because we can actually figure out what's going on and how it fits into the knowledge graph better.
Okay. Great. Thank you.
Thank you.